So Band's rule or band rule, whatever it may be, no problem. So what is this rule? Where it is applicable? Where it is applicable? So see boys, so we have different hybridization. So those are sp hybridization. The shape is linear. Linear means, so there is a central atom, one attached atom, another attached atom. It is a symmetric shape. It has a symmetric shape. That is linear. sp2 hybridization. This is a trigonal planar. Trigonal planar. That means, so there is a central atom, one attached, another attached, another attached. So all the atoms, see here. So this one, all the four atoms are in the same plane. Number of planar atoms are 4 and so this is also symmetric. That means equal, and all sides there is equal. Symmetric structure is there. That is sp3 hybridization. sp3 hybridization means tetrahedral. Tetrahedral. Tetrahedral means, so there is a central atom. So these are the attached atoms, boys. So this is a tetrahedral. Right? This one also symmetrical structure. Symmetrical structure. Okay. So now sp3d hybridization. sp3d hybridization. So see here, sp3d hybridization. So what is this sp3d hybridization? This is a trigonal bipyramidal shape. Trigonal bipyramidal shape. So its structure is like this. So there is a central atom. So trigonal planar. This is a trigonal planar, boys. Already I explained yesterday. So one is above the plane and one is below the plane. This is asymmetric molecule. Asymmetric, boys. Remaining all are symmetric. sp3d2 hybridization. Octahedral. Octahedral. That means, so there is a central atom. 1, 2, 3, 4. It is a square ending. It is a square. 1 above, 1 below. 1 above, 1 below. So this is also symmetric. This is also symmetric. See guys, here 2 attached atoms. That's why coordination here is equal to 2. Here 3 attached atoms are. So number of atoms around this atom is coordination number. Here coordination number is equal to 3. Here coordination number is equal to 4. Here coordination number is equal to 5. Here coordination number is equal to 6. These are the coordination numbers. What are coordination numbers? That is the number of atoms present around the central atom. So this is central atom, 2 attached atoms. That is a 2. This is central atom, 3 attached atoms. That is a 3, 4, 5, 6. So these are the coordination numbers. So see here, coordination number 2, 3, 4, 6. All these cases are symmetric conditions or structures are. But in case of coordination number 5, which is in sp3d hybridization, so that it has a pyramidal shape, it has asymmetric structure. Asymmetric structure. So sometimes it is sp3d hybridization, that's why sometimes it is a square pyramid also possible in some occasions. Square pyramid also possible. Square pyramid, later I will draw. So that means most of the cases trigonal bipyramidal, but sometimes it is a square pyramid. So both these conditions are unsymmetrical cases. So that is asymmetric condition. So in this situation, our bend rule is applicable. So bend rule is applicable in case of coordination number 5. Here, so 2 different structures are possible. Most of the cases trigonal bipyramidal, but sometimes it is a square pyramid. So that means, so and also the structure, that is both trigonal bipyramidal and square pyramid. Square pyramid is like this. It is a square, boys. It is a square. It is one pyramid. That is a square pyramid structure. So this square pyramid and this trigonal pyramid both are asymmetric conditions. Both are asymmetric. So in case of asymmetric situation, the bend rule is applicable. That means in sp3d case. Okay. So now our concept is in sp3d case. See here what happens. So in case of asymmetric condition, what happens? That is sp3d, that is nothing but, so in case of coordination number 5 means, so the structure may be square pyramid or the structure may be trigonal bipyramidal. Trigonal, bipyramidal or square pyramidal. Square pyramidal. These are the two possible structures for us. If central atom is non-metal, so central atom is non-metal, that follows trigonal bipyramidal structure. If central atom is a metal, that follows the square pyramid structure. If it is a metal, that follows central atom is a metal, that follows square pyramid structure. If central atom is a non-metal, that follows trigonal bipyramidal structure. So metal means in most of the cases complex compounds are. That is called as coordination compounds. In case of complex compounds, nothing but coordination compounds. In case of coordination compounds or complex compounds, central atom is a metal. That metal involved in pyramidal, square pyramidal structure. But in general cases, that is PCl5, here phosphorus is the non-metal. In case of this type of molecules, that follows trigonal bipyramidal structure. That means, so some compounds may be in square pyramidal, some molecules in maybe trigonal bipyramidal. But most of the other compounds also may have either square pyramidal or trigonal bipyramidal, but we can't predict. So which one is where? Because so trigonal bipyramidal change it to square pyramidal changes to trigonal bipyramidal in most other cases. That is also possible. So in this situation, we apply bend rule. So see here, that is sp3d hybridization. This sp3d hybridization is the combination of s orbital, 3 p orbitals plus 1 d orbital. S orbital, 3 p orbitals and 1 d orbital. So this is the combination of sp3d. S orbital, no doubt, it is a px, py, pz and a dz square. Boys, this sp3d combination is the combination of sp2, that is s orbital, px orbital and py orbital combination. This combination is taken as sp2 combination, and the pz orbital and dz square orbital, this combination is taken as a pd combination. These two combinations are called as sp3d combination. sp3d is the combination of sp2 and pd. So this sp2 gives trigonal planar shape. This PD combination gives a linear shape. That means, how is that? See here. So this is a central atom, boys. These are trigonal planar shapes. This is a trigonal planar. So these three bonds with this combination, sp2 combination. This sp2 combination, S and px py combination. S, px and py combination. Now, so PD operation, these are the linear ends. These are nothing but one is above the plane and one is below the plane. So linear with blue lines. So trigonal planar with red lines. Trigonal planar with red lines. Blue linear is blue lines. So now see here. So this is trigonal planar shape. This is a trigonal planar shape, boys. Here, so those present in the plane, these that means these red lines, these are called as equatorial bonds. Equatorial bonds. Our red lines are equatorial bonds. That means all those bonds within the plane. All those bonds within the plane. These blue lines are considered as axial bonds. Axial bonds. These axial bonds, that means PD combination gives axial bonds, and trigonal planar combination gives equatorial bonds. Equatorial bonds. These equatorial bonds are strong bonds, my dear boys. These are strong bonds, but these axial bonds are weak bonds. These axial bonds are weak bonds. So that means PD combination gives axial bonds, these axial bonds are weak bonds. So sp2 combination gives trigonal planar. So these trigonal, that is, gives equatorial bonds. Those equatorial bonds are strong bonds. Finally, so these equatorial bonds are strong and these axial bonds are weak. Why, sir, these are weak? Because so the bond length here is low only. That means it is a shorter bond, but this is a longer bond end. So bond length is a high end. So high bond length, as distance between the atoms increases, that bond is weak, easy to break it. Easy to break. That is why it is a weak bond and it is a strong bond. So in this situation, we observe, see boys, here PD combination, PD means no ending. So here S percentage is equal to 0. Here S percentage is equal to 0 in case of PD. PD means axial bonds. So in these axial bonds, S percentage is 0. Low S percentage. That means here S percentage is lower. S percentage is lower. In this case, sp2 case, something S is there in it. Almost S is totally is available. So in this case, S percentage is high. As S percentage increases, strength increases. See here, S percentage is higher. So therefore, equatorial bonds has more S percentage, axial bonds have low S percentage. Axial bonds have low S percentage. Now, so in this structure, so what is the location of atoms? In case of bend rule is mainly for, so different atoms attached. See here, for example, there is a PCl5. There is a PCl5. Here, one central atom phosphorus, 5 chlorine. So no problem. All are five atoms, 5 attached atoms are chlorine. That's why all these positions are occupied with chlorine. No problem at all. But if different atoms are attached, that is, for example, that is PCl3F2. PCl3F2. This is the molecule, boys. That means 3 chlorine atoms or 2 fluorine atoms all together. It is a 5 and same 5. That means PClX times F 5 minus X times. So in this type of molecules, different halogen atoms are there. Different. This is called as fluorochlorocarbons compounds. Fluorochloro compounds. Phosphorus fluorochloro compounds. So in this situation, see here. So phosphorus, chlorine, X times, fluorine, 5 minus X times. Example, PCl3F2. Chlorine, X times, chlorine, Cl3F2. So in this type of molecules, so this fluorine is high electronegative atom. This chlorine is, when compared to fluorine, low electronegative atom. Now, what is the placement of this fluorine and fluorine in this condition? In this condition, where these are located? Where these are located? That means, for example, this is a phosphorus, this is a chlorine, this is a chlorine, this is a fluorine, this is a fluorine, this is a fluorine. Like this is possible. 2 fluorines, 3 chlorines. So different structures are possible in it. But according to Bent rule, high electronegative atom at less S percentage means at axial position. Only high electronegative elements are only at less S percentage, nothing but at axial position. That means fluorine is always high electronegative element means here fluorine atoms are. These 2 fluorine atoms must be located at axial position. That means this is a fluorine, this is a fluorine bonds. This is a phosphorus. Okay, so 2 fluorines only at axial position, they are less percentage. Next one, that is low electronegative element at high S percentage. High S percentage. Low electronegative element means more electropositive. Low electronegative is nothing but more electropositive element, which is at high S percentage. High S percentage means at equatorial condition. At equatorial position. That means, so fluorines must be at equatorial position. This is actual structure. This is not happened, boys. So very, very, very important. If 2 or more different atoms are attached to phosphorus in sp3 dehybridization, high electronegative elements at axial position, low electronegative elements at equatorial position. So this is very, very, very important. See here one more example. That is, for example, alkyl groups are attached. Alkyl groups are R3PCl2. This is the molecule, boys. Alkyl group, organic compound. For example, CH3 thrice PCl2. Here phosphorus is the central atom. This is high electropositive group. This is high electronegative element attached to this phosphoride. Among chlorine and methyl group, chlorine is electronegative and methyl group is electropositive. Now phosphorus, these are the equatorial position, boys. These are the equatorial position. One is axial and another is axial. So here 1, 2, 3 positions are equatorial, 4, 5 positions are axial. Here phosphorus. So these equatorial positions are occupied with equatorial positions with high electropositive. High electropositive. That means 3 methyl groups are occupied at equatorial position and 2 fluorines are occupied at axial position. High electronegative elements at axial. Low high electropositive elements at equatorial. So that is I draw here. So this is high electronegative element, this is high electronegative element at axial position, low electronegative elements at equatorial position. These bonds are stronger than these bonds. That means unequal bonds. Unequal bonds. So bond lengths are not same. So this is a shorter bond, this is a longer bond. This is a shorter bond, this is a longer bond. This bond is easy to break. This bond. That means its bond energy is less. Its bond energy is higher. Bond breaking energy is higher. Okay? So like this. So where those atoms? For example, sir. For example, Cl2F3 is there. PCl2F3 is there. Sir, what is its structure? Sir, what is its structure? See here, what is that structure? Note out, fluorine is a high electronegative element. That means which is at axial position. Chlorine, it is low electronegative, means high electropositive. When compared to this one, when compared to this, it is low electronegativity. So that means high electropositive. This is at equatorial position. So now phosphorus, these are the three positions, axial, equatorial positions, two axial positions. Two axial positions. Here, axial positions are occupied with high electronegativity. So fluorine. One more fluorine is there. No doubt there is no alternative position. That is why one of this is also occupied with the fluorine. So now chlorine. So remaining two positions, no doubt axial positions, and these are occupied with the chlorine. So this is the structure, not like this one. Not like this. Three fluorines here, two chlorines here. So not actual condition. It is not possible, boys. This is correct. This is correct. It is the way to predict what is the position of those elements in unbalanced situation. That means sp3d cases. Unbalanced situation. High electronegative elements at axial positions, low electronegative elements at equatorial positions. So this concept is also helpful to predict the bond angles. So is this more bond angle or less bond angle? So those are also explained this belt rule. See here. So in case of CH2F2, so fluoroalkanes. So your carbon is in sp3 hybridization. So because of different atoms attached, so this is a tetrahedral. Boys, am I audible to you? Okay, thank you. Net problem suddenly dropped. That's why maybe disconnected. And see here, boys. So CH2F2. So it is sp3 hybridization. That means it is a tetrahedron. But different atoms are attached. That's why it is distorted, not a particular. If all hydrogens are there, it is perfect tetrahedron. All fluorines are there, it is perfect tetrahedron. But some fraction is hydrogen, some fraction is fluorine. That's why it is distorted. So we expected all the bond angles at these positions are 109 degrees 28 minutes. But because of its distortion, some bond angles are more than 109 degrees 28 minutes, and some bond angles are less than 109 degrees 28 minutes. Less than. As S percentage is less, bond angle also less than 109.5 degrees. As S percentage is less, bond angle is also less than 109.5 percentage. So less than it. If yes, if S percentage is less, bond angle less than. If S percentage is more, that means bond angle is greater than 109 degrees 28 minutes. Nothing but 109.5 degrees. 109.5 degrees. Here we observe HCH bond angle. HCH bond angle. It is a greater than 109.5 degrees. So FCF bond, this bond angle is less than 109.5 degrees. This is also explained on the basis of band theorem. This is also explained on the basis of band theorem. So these are the applications of this band theorem, and it is very, very important.